Alright guys, welcome back. So in this video here, we're just going to continue where we left off. We sort of introduced two different type of estimate. One is single value of estimate called point estimate, and the other one is using a range of values. So a range of values in mathematics is called an interval. So if you remember from algebra, interval is just a range of values, right? So that's what we're going to start this video with, is a definition of what is a confidence interval would be for this class. So the way we define that, we say that an interval of numbers, so we have an interval of numbers used to estimate the true value of a population parameter. And in this chapter, in this class, we're going to look at just the two values, just focus on two values. Those will be p or mu. And usually P stands for population proportion, mu stands for the population mean. So if we have an interval of number used to estimate a true value, the true value of P or mu, this is called a confidence interval. Okay, so the wording is not quite clear. I mean, in terms of what exactly confidence interval. We know what interval means. How do we interpret confidence interval? So the way I look at this, and I'm trying to make sense myself when I first learned it, is that in life, confidence is what we build based on experience, right? In stats, confidence in the sense of we get the results from numbers of trials or experimenting from sample data. So the confidence in this case here is the level of confidence that what we, the result from the data itself, from the sample, what will be those results come out to be, and from there we get the percent of confidence or the level of confidence come from the data itself. So the next definition we have here is said that the level of confidence is the percentage represent the expected proportion of intervals that will contain the true value of parameter if a large number of different samples is obtained. Now that's a mouthful. Okay, so let's go back and just read that slowly and figure out what's going on here. So we have a level of confidence. Okay, so this usually denote as certain percentage. Let's say we have level of confidence would be 90%. Level of confidence 95. These are just standard, maybe 99 as well. So these would be the level of confidence. So it is a percentage, represent the expected proportion. So the expected proportion of interval that will contain the true value of the parameter if a large number of different samples is obtained. Now, what the heck is that even mean? So what this saying that, okay, it is the percentage that we expect the number of intervals will capture what the actual value that we're trying to estimate if we sample a large number of different sample over and over again. Still, I don't think that's really clear based on just the word there, but I'll try to make it a little more clear using a picture in a second. So let's go to a different note here. So I'm gonna open a new one. Let's see if we can interpret level of confidence here. So let's say geometric interpretation of level of confidence. All right, now suppose we have suppose we're using the same example that we did earlier, and that example was trying to estimate the actual percent of the number of adults, the proportion of adults who uses Facebook. So let's say we let P be, we're trying to estimate P be the percentage, the proportion of all adults who says they have a Facebook page. Right, so that was the example in the previous video. Now suppose that somehow we know that P is around, 60%, around there. Okay, so let's say this is stand for P, 60%. Okay, So what the level of confidence saying that if we were to sample, let's say we're looking at same, sample size. Let's say we look at N, 1847. That's the sample size of adulthood survey. Let's just look at the result or the sample data of 10 different groups of 1847. Now in the previous video we noticed that for each of these samples 1847 we get different point estimate. So from that we say that we expect to have obtain 10 different p hats. So that was just from this first example here, right? So if we look at different sample of 1487, we expect to get two different p hats or sample proportion. 1487, did I get that right? Yep. So in the next video I'm going to show you how to construct these interval. Now suppose that we done that part, all right? Suppose we done that part and we construct these 10 intervals here. Suppose we have these intervals. Let's say this go from 0.4 to 0.8. Suppose we construct these intervals and here's our following intervals, right? There, 2, 3, 4. I think these should be the same size. So let me just go ahead and erase that. 3, 4, 5. How many we have so far here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose we had 10 intervals collected from 10 different group of sample size of 1847, and there's happened to be one of them that looks like this. So as you can see there, each of these interval, the one in the greens, capture the actual value of p, right? So they're right in the middle there, except for the purple one there. Okay, so n equal to 1847. Each of this interval is constructed from that sample size of 1487, and from there we construct a confidence interval, and we say that from this 10 here, as you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 6, 9. So we say that 9 out of 10 intervals, all the intervals that we constructed, contain p equal to 0.6. So that's what p is, right? So 9 out of 10 is 0.9, and that's about 90%. So that's gonna be your level of confidence there, level of confidence. In the sense that if we sample large enough data, our confidence comes from the fact that the result of these is interval. The proportional interval who capture that actually capture the true value of proportions is 90%. So that's where the 90% come from. Is we're 90% confident that the intervals that we constructed, 9 out of 10 of them will capture the actual value of p. So there's another whole concept of where we get this from as well, and that would usually take us another 30 minutes or so to discuss where this, how do we know it's containing p and things like that. And that's come from that result. What we need this distribution here, distribution of p hats, and that's another concept that we haven't discussed about. But by looking at distribution of all the p hats of sample size of 1847, it'll help us visualize this a little more better in terms of how do we know that this percentage of confidence intervals capture the actual p hat, not p but p itself. So I don't know if that helps clear up a little bit in terms of what level of confidence is. Let's go back to the definition here. It says that it's the percentage that we expect to see the number of intervals that will capture the actual true value of parameter if we sample large enough of different sample data. And so that's what the level of confidence is saying. In terms of the visual, it's saying that if we construct 10 intervals, then we expect around 9 out of 10 to capture the value P, and that's what the 90% confident interval will come from. Okay.